Hello students. So in this lecture today, we are going to complete the theory part of chapter 8 motion of ninth class physics. Learning outcomes of today's lecture are: derive the three equations of motion analytically. Second, what is uniform circular motion and give an example for it. Now, let us try to achieve this first question, first learning outcome. Derive the three equations of motion analytically. Generally, I have seen students prefer this method, but in your syllabus, graphical method is there. But if in exams the question comes just to derive the three equations of motion, they don't ask you whether graphically or analytically, then you can prefer this method because it is easier comparatively. Introduction part is just the same as we have done in the case of graphical method. Consider a body moving in a straight line with uniform acceleration A. Let its initial velocity, that is its velocity at time t is equal to 0, be u. Final velocity, that is after time t is equal to v. Magnitude of displacement covered in time t is S. So this is just the introduction of all the letters that will be used in our three equations of motion. Now to derive the first equation of motion, this introduction part is common for all the three equations of motion. We know that first equation of motion is v is equal to u plus at, and it is also called as velocity time relation. Now let us continue. By definition, we know what is acceleration. Acceleration is change in velocity in unit time, or we can say rate of change of velocity. So, acceleration A is equal to change in velocity divided by time taken for that change. That is equal to change in velocity means final velocity minus initial velocity divided by again time taken for that change. We can write A is equal to v minus u, final velocity is v minus initial velocity is u divided by time taken for that change is t. So A is v minus u upon t. And below that you can write, I have written it here, but you can write these steps one below the other. If A is v minus u upon t, therefore v minus u is equal to at, and at the end you can write v is equal to u plus at by taking u on the other side. So we have arrived at the first equation of motion. This is the derivation of first equation of motion, and I hope you have understood this as it is very simple. Now students, we know that the second equation of motion that we are supposed to derive is S is ut plus half at square. For this, if it had been uniform motion, then I can take, we know that velocity is displacement upon time and displacement will be velocity into time. But this is the case of uniformly accelerated motion. So I cannot take displacement as velocity into time. I have to take displacement as average velocity into time. So let us see how I have taken that. I can first write average velocity is total displacement over total time. Therefore, total displacement is average velocity into total time. So S is equal to, I have denoted the average velocity by VF, and then into total time is t. Now for average velocity, I have not told you because there was no requirement before, but you should know that other than this is one basic formula for average velocity which is valid for all kinds of motion. But for uniformly accelerated motion, there is one special formula for average velocity, that is V average is u plus v divided by 2, where u is the initial velocity, v is the final velocity. It means for uniformly accelerated motion, we can write average velocity is average of the initial and final velocities. So, putting the value for v average average velocity here, u plus v upon 2 into t. Then continue here. Here what I'll do, I know in this relation v is not required. So I'll put the value of v from first equation of motion, that is v is u plus at. So v is u plus at. So in this step I have just put the value of average velocity formula I have written. Here I have written the expression for v from first equation of motion. Now let us simplify this. U plus u, 2u plus at, rest is same. Here what I have done, I have multiplied each term in this bracket by t. So it becomes 2ut plus at into t is at square divided by t. In the next step, I have divided each term by 2. So here in the first term, 2ut upon 2 gets cancelled, plus at square upon 2. So finally I get s is equal to ut plus half at square. I hope you have understood this derivation very simply, because it is very simple. You have to just remember one thing, that distance covered here is average velocity into time, and average velocity formula for uniformly accelerated motion is u plus v upon 2. This relation is also called as displacement time or position time relation. Now, third equation of motion, that is v square is u square plus 2as. We know this relation is also called as displacement velocity or position velocity relation. Now here again we'll continue in the same manner as we did in the case of second equation of motion's derivation. Average velocity is total displacement over total time, and total displacement is average velocity into total time then. S is equal to v average into t. For uniformly accelerated motion, we'll put the value of v average. It is u plus v upon 2, average of initial and final velocities, into t. Then what I have done here, u plus v can be written as v plus u upon 2. And here in the second derivation I have put the value of v. But in the third derivation, I see in the formula, in this equation, I don't have time. So here I don't want t. So I'll put the value of t from first equation of motion. We know first equation of motion is v minus u is at. So we can write t is equal to v minus u upon a. So from first equation of motion, putting the value of t as v minus u upon a, I have written here. Now here a plus b into a minus b can be written as a square minus b square, and hence I can write s is equal to v square minus u square divided by 2a. Thus v square minus u square is 2as, and thus finally v square is u square plus 2as. This is our third equation of motion. Hope you have understood the derivation of three equations of motion by analytical method. Now students, we have finished the derivation of three equations of motion. This one more relation is there, which is not there in your 9th class syllabus, but whenever students go for any coaching class or give any entrance exam, this formula is frequently used. So it is an important formula from that point of view. That's why I have not written this under the learning outcome. No need to by heart the derivation for your class, but at least you can understand here because it will be useful for your exams, entrance exams. Now pay attention here. We are going to derive a formula for distance covered in nth second. It is not n seconds, it is nth second. For example, distance covered in 3rd second, 4th second, 5th second, like that. Okay, so for this we'll be using the second equation of motion. Let distance covered in n seconds be Sn. So in n seconds, distance covered is Sn. So we can use the second equation of motion. Sn is ut plus half at square, where time t is equal to n seconds. So just put the value of t as n here. So it becomes Sn is u into n, nu, plus half into a into n square, half a n square. So Sn is nu plus half an square. It was very simple, I guess, here. Now, to find the distance covered in nth second, what I'll do, write an expression for distance covered in n seconds and then distance covered in n minus 1 seconds. For example, if you want to find out distance covered in 4th second, what you can do is, you can find out the distance covered in 4 seconds minus distance covered in 3 seconds. Whatever answer you will get, that will be the distance covered in nth second. So here I have written an expression for distance covered in n seconds. Now I'll write, in the similar way, I'll write the expression for distance covered in n minus 1 seconds. So I'll denote it by Sn minus 1. Sn minus 1 is what? It is ut plus half at square from second equation of motion, where t is equal to n minus 1. So I'll just put the value of t as n minus 1 as I have shown here. U into n minus 1 plus half a into n minus 1 square instead of t square. Now I'll open the brackets here. U into n, nu minus u into 1, u plus half a, and in the bracket I've written the expansion of that. We know that a minus b whole square is a square minus 2ab plus b square. So using that formula, that comes out to be n square minus 2 into n into 1 minus 2n plus 1 square, that is 1. Now I'll open the second bracket. In the next step, nu minus u plus half na half. Yes students, sorry, here it was un plus half an square, so it has to be nu plus half n square a, and by mistake it was initially written as half an square. So just remember, Sn is nu plus half n square a. Okay, so make the correction here. And similarly here, when we proceed, here we get half a into n square. So it becomes now here nu minus u plus half n square a minus half a into 2n plus half a. That is equal to, in the next step, nu minus u plus half n square a, 2 gets cancelled, minus na and plus half a. So we have derived, finally, we have got two expressions. Sn, distance covered in n seconds, Sn minus 1, distance covered in n minus 1 seconds, just by using the second equation of motion and by putting the value of t. T as n here, t as n minus 1 here. So students, now we have found an expression for distance covered in n seconds and distance covered in n minus 1 seconds. So if we denote the distance covered in nth second by Snth, I can write distance covered in nth second is equal to distance covered in n seconds minus distance covered in n minus 1 seconds. That is Sn minus 1. Here I have just put the value of Sn that we have derived just now, nu plus half n square a minus, and I have written that expression which we have found just now for Sn minus 1. So now here I am going to open the brackets. Nu plus half n square a, open the bracket, minus nu, minus minus becomes plus u, minus plus becomes minus half n square a, minus minus becomes plus na, and lastly minus plus becomes minus half a. In this case, now 4 terms gets cancelled. Nu gets cancelled with minus nu, half n square a with minus half n square a. So we are left with u plus na minus half a. Now u is here, plus take a common out, and then we are left with n minus half. Although this can be the final expression, but still in your books or if you see this formula anywhere, this is a final expression that is used just to make the calculation simpler. Here u plus, here we are multiplying and dividing each term by 2. So a by 2, I have divided this by 2, so I have to multiply each term inside the bracket by 2. So what I have done, a by 2 inside the bracket n, I have to multiply it by 2 because then only a by 2 into 2n will be a into n. So I have multiplied n by 2 minus, again I have to multiply half also by 2. If I multiply half by 2, 2 gets cancelled and we are left with 1. Try to understand this step properly. What I have done, I have multiplied each term in this bracket by 2 and divided also it by 2, but denominator I have taken common out. So u plus a by 2 into 2n minus 2 into half is 1. So students, no need to by heart the derivation, just remember this formula which can be very useful for your other exams. Not your board exams but for your other exams. S nth, distance covered in nth second, is u plus a by 2 in the bracket 2n minus 1. So here we are going to complete the last theory part, last definition, last topic of this chapter, motion. Uniform circular motion. You know students, you can easily say when a body is said to be in circular motion, when it moves along a circular path. Now, uniform circular motion means that a body is moving along a circular path, but it is also covering equal distances in equal intervals of time. So you can write, when a body covers equal distances in equal intervals of time along a circular path, it is said to be in uniform circular motion. Initially you have studied just uniform motion. What is uniform motion? When a body covers equal distances in equal intervals of time. So this is also a case of uniform motion only, but since the path is circular, we call it uniform circular motion. So we can write, when a body covers equal distances in equal intervals of time along a circular path, or we can say when a body is moving along a circular path and covers equal distances in equal intervals of time, it is said to be in uniform circular motion. Now let us try to understand this in more depth. Now students, for example, if I consider this to be a closed path, it means you start from A and you move along this direction, then this, and then this. So in this case, you are changing direction 4 times and then you reach finally at A. Suppose if now 4 times you are changing the direction, and suppose if you change the direction more number of times, it means instead of this quadrilateral, you take a, let us say, pentagon, you draw a pentagon here, okay? And then you can proceed with hexagon, heptagon, so on. You know that if you increase the number of sides of this closed figure, okay, these length parts will go on decreasing and the number of corners will go on increasing. It means you will cover some distance and you will immediately change the direction. For example, here, suppose if this is A, then you are moving along this path, covering smaller distance and then changing the direction. This arrow should have been, just wait. So when you start from A, let us say now you are moving along this path. Here 1, 2, 3, 4, 5, 6. 6 times you change the direction. Here you were changing the direction 4 times. Here you are changing the direction 6 times. And comparatively you covered smaller distance and change the direction. Suppose you continue this, you decrease these path lengths and increase the number of corners. Finally, what do you get? You get a circular path. It means we can say that when a body moves along a circular path, it changes. Here it was changing its direction 4 times. Here it is changing its direction 6 times. And here it will change its direction infinite times. It means every next step the direction of motion will be changed. And what is direction of motion? That is the direction of displacement. So when a body moves along a circular path, every next point or every next step, the direction of motion changes, and hence the direction of displacement changes, and we know velocity is displacement upon time, and velocity has the same direction as that of displacement. So when a body moves along a circular path, the direction of motion, so the direction of displacement, and hence the direction of velocity changes continuously. So if the body is moving along the circular path in this anti-clockwise direction, we can say at any point what is the direction of displacement. We can use the word tangent here. Students, you must not have heard this word before. Related to circle, you know what is circumference, you know what is area, you know what is radius, diameter, you know about chord also. Chord is a line segment joining any 2 points on the circle, on the circumference of the circle, and we know diameter is the greatest or the largest chord. Similarly, we have one more term, tangent. Now here I have drawn a tangent. What is tangent? Tangent is a line which touches the circle from outside at just one point. It means a line which touches the circle at only one point is called as tangent to the circle. So what is common between tangent to the circle and the circle? Only one point. It means at every point we can draw new tangents. At every one point we have only one tangent. Okay? And so we can say here that at any point, suppose at this point, what is the direction of displacement? It is along the tangent to the circular path at that point. And same will be the direction of velocity. So there also I have shown the tangent. At any point you can draw the tangent in that way. You can draw a line just touching the circular path at one point and show the arrow this way if the motion is anti-clockwise, and otherwise you can show the arrow that way if the motion is clockwise. So if I ask you what is uniform circular motion, you can easily define. Now if I ask you what is the direction of motion or direction of displacement or direction of velocity of a body in uniform circular motion, your answer should be at any point the direction of motion or the direction of displacement or the direction of velocity is same, and it is tangent to the circular path at that point. So in uniform circular motion, if I ask you what is constant, you will say speed is constant. Magnitude of velocity is also constant, but direction of displacement and so direction of velocity changes continuously. So if I ask you students that it is a uniform circular motion in this, is velocity constant like in the case of uniform motion along a straight line? No. In this case velocity is not constant, although magnitude is constant, but since the direction is continuously changing, so velocity's direction is continuously changing, so there is some acceleration. And we can say uniform circular motion is an accelerated motion. Remember students, I have not used the word uniformly accelerated motion. I have just used the word accelerated motion. And so students, when a body is in uniform circular motion, speed is constant, magnitude of velocity is constant, but direction of displacement and velocity changes continuously. And you know what is the direction? Tangent to the circular path at any point. Now, so obviously because the direction of velocity is changing, so it is an accelerated motion. And remember, acceleration in case of uniform circular motion is called as centripetal acceleration. Centripetal means center seeking or towards the center. And remember, from the name itself we come to know the direction of acceleration. Center seeking, towards center. It means when the body is at this point, this is the direction of velocity and the acceleration direction is towards the center along the radius. So when the body is there, that is along the tangent is the direction of velocity and acceleration is along the radius towards the center. So acceleration in uniform circular motion is having direction along the radius towards the center. We can say at all points the direction is changing. Every point the direction is along the radius towards the center. And what is the magnitude? Magnitude of acceleration is constant, although the direction is changing. What is it? Just remember this value. We are not going to derive this formula. Centripetal acceleration is v square upon r, where r is radius of the circular path and v is speed or magnitude of velocity. Okay, so I hope you have understood this uniform circular motion well, and you will remember that direction of velocity is continuously changing, and in this case, so acceleration is there, which is called as centripetal acceleration. Its direction is along the radius towards the center at any point. So direction is continuously changing of acceleration. Every time it is along the radius towards the center, and magnitude is v square upon r. I hope the chapter is clear to you, students. So with today's lecture, we have finished the theory part of chapter 8 motion. This was the first chapter of physics of your 9th class, which is numbered as chapter 8. If you have understood this chapter well, please do like the videos which you have understood very well. Okay, and we'll continue with the numerical part in our next lecture. Thank you, students.